Hi, and welcome to question 8 of the Leave Cert Order Level Paper 1 from 2021. As always, if you want a copy of the notes I'm working off, just send an email to shanetroy@gmail.com. And if you like these videos, don't forget to hit the subscribe button. So question 8 here is kind of geometry slash algebra slash area volume to a certain extent. So a square sheet of cardboard of side 10 units is used to make an open box. Okay, so we have a sheet of cardboard of side 10, so the whole length there is 10, okay? And this box has been folded into I suppose, this shape here. Squares of side x units, where x is the limit of r, so this means any number, okay? Don't worry about that, are removed from each corner of the cardboard, and it is then folded along the dotted lines. So basically, this bit here is making the edges of the actual box itself. In a sense, this would be wasted material. Okay, so the part A here says the length L, breadth B, and height H of the box are shown in the diagram here. So the length, the breadth, and the height. Now, I know straight away that height, okay, is going to be the same as this here. Okay, so that's going to be X. Now the breadth here, it would have been 10, except it's 10 take away the bits that were coming out here. So this bit, this X and this X. So it's 10 take away X, take away X. On the far side here, does it say it's square? Oh, it's just a square. Now it doesn't look like a square here because I've stretched it out for the editing. So that's actually 10 there. So that'd be the same situation, the L. 10 take away X, take away X. Now, I think I've got a fairly good handle on what this is going on. Sometimes it's worth reading it 2 or 3 times, and I have a very bad habit of getting stuck in and then realizing I haven't read the question properly. Now, I'm fairly familiar with this. It's been a while since I made up the notes, but part A then says, the length L, the breadth B, the height H of the box is shown above. Write L, B, and H in terms of X. So I've done that. So L is equal to 10 take away 2X. The B is the same thing, 10 take away X is the same thing as 2X. And then the H is equal to X. Now, if you get that, it's fairly handy. If you don't, you're struggling. Okay. If you did some manipulation with the 10 and the X, you might get the 2. If you're absolutely struggling with this question, this is where they're trying to do area using algebra. So they're trying to express things in terms of X. I have a fairly good idea what's going to happen, going forward because of my familiarity with these kind of questions. But let's get stuck in. So part B says, show that the volume of the box can be written as this function. Now I prefer to write that generally when I'm using function notation as using the x is not part of it. V of x is basically the volume. Okay, it doesn't necessarily look like that with the way they express the x, but it's purely editing reasons. Now volume, okay, is equal to length times breadth times height. Now in this situation, that's 10 minus 2x by, the breadth was 10 minus 2x times the h was x. So length times breadth times height. Now, all I have to do now is multiply them together. I can do this, I can probably do these two together. Now, this is not, my work is not tidy, but I'll do it over here if I can. So 10 minus 2x by 10 minus 2x. And this is effectively rough work. Now, there's different strategies for multiplying a 2-term bracket by a 2-term bracket. I'm going to do one of them. A different video, I might do a different one. But in the one I learned is I take the second bracket and I write it out twice. Now, just to note, in this case, the two brackets are the same, but that's not always the case. We then take the first term here and multiply it into the first bracket. We take the second term here, the minus 2x, okay, and we multiply that into the second bracket. Now, basically, once I have that done, I want to go left to right and do the multiplication, remove the brackets. So 10 times 10 is 100. 10 times minus 2x is minus 20x. Minus 2x by 10 is the same as minus 20x. Now, minus 2x by minus 2x, minus by minus is a plus. 2 by 2 is 4. X by x is x squared. Now, generally, we write these with the x, the largest power of x first. Then I can combine these two. They're the same type, so they'll combine. Minus, I owe you 20 apples. I borrow 20 more off you. I now owe you 40 apples. Not sure why I borrowed apples, but whatever. And then the 100 doesn't change because there's nothing to change it. So 10 minus 2x times 10 minus 2x is the same as this thing here. They're the same thing. So I can swap them out in the original problem. Now let's just go ahead and do it. Apologies for my bad writing. Now here, to finish off, I need to make sure I multiply all three terms here by x. Now I'm going to go to the answer on the next page because I'm sure it's prettier. So there's the initial setup, length by breadth by height. Though I don't know why I don't say it. Length by breadth by height. Let's go back and amend that. There's the calculation I did, the rough work over here. Just on that, that's where I left off, although I put it the x squared going downwards. So all I need to do now is do the multiplication. Okay, so 100 by x is 100x. Minus 40 by x is minus 40x squared. 4x squared by x is plus 4x to the power 3. Now, is that the same as my original function? It is, although it doesn't look like it, but we should always do the largest power first. So the 4x to the power 3 is first. The minus 40x squared is second. And then the 100x, the smallest power on the x is last. Okay, if there was a number, it would come after that. Are they the same? Yes. Okay, so you've shown that. And that's it. Okay, so that's part A and B. Now, part C here is saying, explain why a box of height 6 units cannot be made from the sheet of cardboard. Now, luckily, I've had a chance to go through this. If you remember, we said that length was equal to 10 minus 2x. Now, we also said that breadth was equal to 10 minus 2x, and we said that h was equal to x. Now, if we have a box of height, replace that. That should be x. Now, we've just been told that the height of the box is 6. Okay, so we know that the height of it is 6. Now, if we take any of these, either of these, L, and if I put 6 instead of there, 10 take away 2 times 6, that's the same thing as 10 take away 12, which gives me negative 2. So the length of this box, if it has a height of 6 units, would be negative 2. You can't have a negative length. It's impossible. And that's your proof. That's why it cannot be made from in that particular dimensions. Okay. Hopefully that makes sense. I have the notes here on the next page. So you see that we said if the height is 6, then x is 6 because we identified h to be the x in part 1. We said that here. And so if x is 6, the length is 10 minus 2 times 6, so it's negative 2. Negative length is possible. Now the next part then is part D and E, and there's a whole pile of things going on here. This is bog standard functions questions. With a function, okay, we have an input. Okay, now we generally call that x. Goes into your function, okay, and gets changed or transformed by whatever the rule is. In this case, that's the rule. And it outputs the f of x, okay, which is the changed input, and that's called the output. Now, another way of expressing that is y. If we were using x, y coordinates, f of x is y, x is x. So we're told the different values of x that we're using in this particular scenario, and we're asked to complete the table. Okay, so there's a lot going on here, and I suppose the first thing would be to read it, complete the table below to show the values of v of x is equal to 4x to the power 3 minus 40x squared plus 100x. Where x is an element of r, that doesn't really matter, it just means x is any number. For the given values of x in the domain, now the domain just means the x values, between 0 and 5. Now they give you a hint and they go 0. Now they go up in 0.5s, which we normally go up in full whole numbers, but that's fine. 0, a half, 1, 1.5, 2, 2.5, 3, etc. Okay. Now they've given us a few calculations here to help us out. But this is where your calculator comes into its own. Okay. So if I can find my calculator and just clear it off. Now I'm going to put in this function here with empty brackets. We don't always, let me just clear that. We don't always do that, but it's in a sense it's a way of putting in a variable without that functionality being there, if you get me. The blank brackets mean unknown. Okay. Now hopefully I'm just trying to get there. Plus 100, and we have brackets there. So everywhere in the original function we were given, where we'd have x, I've given an empty bracket. Now I'm going to go back. The first run there, they said the x value was 0. Okay. So I'm just going to go back all the way, replace that with 0. Okay, now press equal. That gives me an answer of 0. So the v of x answer is 0. Now what I might show there is, I might show one calculation. Okay, if my answers are wrong for whatever reason, okay, this would get me at least the 5 marks because I'm doing the right thing. Okay, and that's equal to 0. So that's the calculation. That's fine. Okay, if I got it wrong, I'll probably get it wrong all the time. It would be a consistent error. In fact, you might actually get the 18 to 15 marks, to be honest. Because again, it's not your fault because you just had the right function in the calculator. If the person, the grader, sees all wrong answers with no work shown, we assume it's just guesses because what else can we assume, you know? Now, once I've done that, I'm going to go back and I'm going to replace 0 with, I could test it with 0.5. I should test it with 0.5 to make sure that this is what I'm being asked. If I put in 0.5 instead of x everywhere, I should get 40.5. Okay, and I do. Okay, so this is working, the strategy. Now, hopefully you can do that yourself. I'm just going to take this from the previous, from the notes. I can see the second slide. So that'll end up being 64. That'll end up being 73.5. Now I'm looking at a smaller screen and I hope my eyesight doesn't let me down. 62.5. Okay, I'm struggling to see it. 48. 31.5. And then 16. Damn it. 48. Now I made a mess of that, so I went ahead and just removed it. I think I'd forgotten to write in the 72 was the problem I had. Now, that's the right answers. You can check that with your calculator. It's just a matter of doing the grunt work of changing the x value each time, pressing equal, then cursoring back and changing the value again. And just do that, what was it, 1, 2, 3, 4, 5, 6, 7, 8, 9 times, okay? And you get the answers. Then we're going to graph it, okay? So the x is the x, the v of x is basically the y. So the first value there is 0 on the x, 0 on the y is down here. Then a half on the x, 40.5 on the y is probably somewhere around here-ish. 1 on the x, 64 on the y is somewhere around there. 1.5 on the x, 73.5 is probably about there. 2 on the x, 72 on the y is around there. Then 2.5, 62.5. Then 3 on the x and 48, somewhere there. Then 31.5, maybe there-ish. 4 and 16 is probably somewhere around there. And then 0 on the x, 4.5 and then 4.5 is probably there. And then our last one back at 0. Now, excuse me for drawing this prop badly. Okay. This is not supposed to be drawn with a ruler. Now, it's terrible, but again, there'll be a lot of give with this because again, people may not have good hand-eye coordination. And it's obvious the person knows what they're doing. It's just they may not have the physical capability of drawing that well, like myself. Okay. So my answers now aren't going to be as good as I'd like them to be because the graph maybe isn't as good as I'd like. But it's just on this graphics tablet, it's not as easy as it looks. And hopefully on pen and paper it might be a little bit easier to do. So part 1 here says it wants me to find out the maximum volume of the box. Now the volume, okay, this curve is telling you the volume as the height changes basically. The maximum volume is up here. Okay, so that would be roughly, I'm going to say roughly, so max volume is roughly, I'm going to say 85. I'm probably wrong. Okay, we'll see in a second what the actual answer is. Actually, sorry, it can't be 85, sorry. Between 70 and 80, so 75. Okay. Now, I don't need units there, so that's good. Okay, the next one then says the values of x for which a box will have a volume of 30 units cubed. Now, it's this line here. Okay, wherever that line touches the curve, drop it down in a bloody straight line. It's this one there, so that's what, 0.3. 0.3, and the other one drops down around 3.6 maybe. Now again, my graph is terrible. I'm making it worse. Now the last part 3, says the volume of the box when x is 2.8 units. So this is the x-axis. We're looking for 2.8 on the x-axis. It's probably somewhere there. And you're bringing that up to where it hits the curve. Okay. Now we want to read off what's the volume that corresponds to that. So you bring a line, now using a ruler at this stage. Okay. Bring it across, and it's roughly 51, maybe 52, and go 51. So what the big important thing here is that this line, the curve you've drawn, represents the volume changing as the height of the box changes. And we're trying to optimize the situation. This is the whole area of math called optimization, where you're looking at what's the best, most efficient way of doing things. And if that's what the world is, if you can make a product more efficiently, you can sell it for cheaper, people will buy it, and therefore you can outcompete your competitors, or if you want to go down that capitalistic route. Now, just look at the answers I actually got. This is the answer done better. So we have the different values. Okay, I plotted them. And I suppose what's saying here, let's say for some reason I couldn't plot this. I could, any graph you make up here, the answers you choose from the graph you just made up, assuming you can't do it, would be accepted as correct in part 1, 2, and 3. Now the graph won't get any marks and the table won't get any marks because they're wrong. But the work off that would get marks. So we said there the height there comes off the maximum height. I think it says 75. The better one, actually, that's agreeing with the marking scheme is 74. But there is a tolerance, and it'll be based on your graph. Okay. Then the two values, we said that roughly. I forget what I said exactly, but I definitely was 0.35, and I think let me just flick back. Okay, not too bad. I said 3.6. Okay, so it's not terrible. And the last one, the blue line there, I brought up from 2.8, hits the curve, goes across, and I said 51. Okay, they said 54 in the market scheme, which I'm off a little bit, but yeah, my graph, hopefully you would agree with my graph. And that's it. So that's the end of question 8, okay, of the Leaving Cert Ordinary Level, paper 1 in 2021. If you want to copy the notes I'm working off, just send an email to shanetry@gmail.com. And if you like these videos, hit subscribe to get access to more playlists. Thanks.